Today we're going to look at composite functions. So let's just take a minute to review our basic function notation. So on the left side of the screen, we have the function f given as 3x minus 1. And we are given some x values. Remember, that is part of the domain. And we're asked to evaluate the function at those values. So here we want to find f of 2, meaning everywhere there is an x, we replace it with a 2. And I know we've done this before, so you could probably work this math out in your head. So we want f of 5, so that would be 14. And then we want f of 6, and that would be 17. So we're just evaluating functions. Let's practice that again with the g function. So we want g of 2, so that would be 2 squared plus 2. We want g of 5, so that's 5 squared plus 2. And we want g of 6, which is 6 squared plus 2. Again, just basic evaluating functions. So what is a composite function? The composition of functions. The composition of the function f with g is denoted by this symbol. Now, some students have called this fog, but it really should be said as f of g, and is defined by the equation, this symbol of x, and it really means to find or evaluate f of g of x, meaning this g of x is the input. Just like these values were the input for f, these values were the input for g, now g of x is the input for the function of f. So the domain, which is the input, of the composite function f of g is the set of all x such that x is in the domain of g, because we had to start with that, and g of x, again, is the domain or the input of f. Now, I know that's a mouthful, but it's really easy. So let's look at this first example. And again, we're going to use these functions above. So we're asked to find f of g of 2, meaning we need to find g of 2 first. Start from the inside out. Think about parentheses. Well, if I go up here, I already found g of 2. G of 2 was 6. So now I go to my f function and I want to evaluate f of 6. Well, we did that already, and f of 6 is 17. So think about it as a roadmap. Where do I go first? So this is g of f of 2. So again, we do the inside first. I need to evaluate that. So f of 2 is 5. So we replace that f of 2 with just the value of 5. And then I go to my g function and find g of 5, which was 27. Again, pretty easy. But what happens when you are given a graph? So in this, we have just some colors to help us make us see some things a little bit easier. My g of x graph is in red, and my f of x graph is in blue. I'm going to try to get it all on the screen. And so now we're going to go through these examples using this graph. So first I want to find f of g of negative 3. So I need to find g of negative 3, which means I'm going to use my g graph, which is my red one, and go when x is negative 3, negative 1, negative 2, negative 3. X is negative 3. What is my y value when x is negative 3 on the g function? So it's saying when x is this on the g function, what is y? And it is negative 1. Now I go to my f function, which is in blue, and I look at when x is negative 1, what is y on my g function. And it's a little bit bigger than -1. So let's just call it -1.1, just kind of estimating that value there. Let's try another one. So we want to find g of f of -5. So again, I would need to do this part first. So I go when x is -5, so that's over here. What is my y value on my f function? And it is off my screen. So when x is -5, what is my y value? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's at -10. So this is g of -10. So what's my road map now? I go to x is -10, and what is my y value on my g function? And it is +1. Why don't you try the next one, pause the video, and see if you can get the right answer. All right, let's see how you did. So we have f of g of 0. So again, I do this part first. I find when x is 0, which is right here, what is my y value on my g function, which is 2. So now I go when x is 2, what is my y value on my f function, and it is -2. Did you get it right? I hope so. Let's keep going. So we have g of f of 3. So f of 3 first. So that means when x is 3, what is my y value on my f function, which is the blue one on the screen, and that is -3. Now I go to -3. What is my y function on my g, which is the red one, and that is -1. Hopefully you're kind of catching on. It's really pretty easy when you have the graphs. Okay, so we want g of 7. So we have 1, 2, 3, 4, 5, 6, 7. Well, what is my g value? 0. So now I want to go when x is 0. Don't go up to the red one. I'm on my blue f function. What is y? And that looks about like -1.5. All right, now the next one, f of 9. Wow, that sounds weird, but let's just take it as a road map. It says to go to 9 first on the x-axis, and it says look at the f function. So what is my y value on the f function? It is -1. Now I go to -1, and again, I look at my f function because I want to evaluate the function at f again. And again, that looks about -1.1. Now, why do I have an asterisk by this next one? Well, let's find out. So I want to find g of f of -7. So let's see. This is -7, and I want to know what is my y value on my f one. So it's way up here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so it's 9. Couldn't fit it all on my screen. So that says to find g of 9. So now I go out here to 9, but look, there is no g function. The g function stops here, which means this was not in the domain. So this is not possible. Even though -7 was in the f domain, f of -7 was not in the domain. It's not a value that is defined on the g function. So that's looking at it from a graph perspective. Let's now look at it from an algebraic perspective. Okay, so we're going to be asked to find f of g of x and g of f of x. All right, so we're going to start with this one. So f of g of x. This is your input. Well, what is g of x defined as? X squared plus 2. So I'm going to replace g of x with the definition of x squared plus 2. Now we've done this before. What does that mean? This means to take x squared plus 2 and replace x in the f function. So this is 3 times x squared plus 2 minus 1. Again, replacing x with a different expression, x squared plus 2. I highly recommend you using those parentheses. And now I'm just going to simplify. And that is f of g of x. Now what happens when we go the other way? Will we get the same answer? Maybe. Let's give it a go. So now I want to find g of f of x. So this is g of f of x. So that means I take what f of x is, which is 3x minus 1, and I put it in there. Okay, so I'm going to have g of what is f of x, 3x minus 1, and then I replace the x with 3x minus 1. So I'd have 3x minus 1 squared plus 2. All right, so if I FOIL that out, that's 9x squared minus 6x plus 1 plus 2, which is 9x squared minus 6x plus 3. And that is g of f of x. So again, it's just a roadmap, but I want you to notice we did not get the same answer. Now, that's going to come up in a later topic, but this is how we just traditionally find algebraic composite functions. Okay, so let's do this one. F of g of x. That's f of g of x. So replace g of x with its expression, which is the square root of x plus 2. Then take this into the f function and replace x. So we have the square root of x plus 2 squared. Well, isn't that nice? So f of g of x equals just x plus 2. Let's go the other way. G of f of x. So g of f of x. What is f of x? It is x squared. So now I'm going to replace this with x squared. So that's the square root of x squared plus 2. And that's all we can do with that. You cannot take the square root of that, just that x squared part. And again, very different composite functions. On this one, we're just asked to find f of g of x. Don't start panicking. I know there's fractions. It'll be okay. All right, so we want to find f of g of x. So g of x is 2 divided by x. So what does that mean? It means in the f function, everywhere there is an x, we're going to put 2 divided by x. Okay, so everywhere there is an x, we're putting 2 divided by x. And then I'm going to ask you to simplify that. Okay, so there's a lot of different ways you can simplify complex fractions, which are fractions within fractions. One of the easiest ways is just to multiply everything by the common denominator. Now, since that's 3 over 1, the common denominator would be x. So if I multiply this by x over 1 and this by x over 1. Now, really, what I am doing to this expression is multiplying it by x divided by x, which is just 1. You can multiply anything by 1 without changing the values, and that is what I'm doing. Okay, so let's see. So these are going to divide out, and I'm just going to have 2 plus 3x. That's all you have to do. Again, don't panic on those fractions. So composite functions, remember, is just denoted by this new symbol. F of g could be g of f, could be f of f, but it's just a roadmap. We've got different inputs. Remember, this is going to be your input, just as x was your input here, x was your input here, and just go slowly, you'll get it.